Algebra 1 Inequalities Test Review, page 4. I will go more quickly because we have some experience now. If you have questions, email me. Okay, we have a solid line, so y is less than or equal to, my slope is 1, 2, 3, 4, 1, 2, 3, my slope is 4 over 3, my y-intercept is -4, my line is solid, I've shaded below, y is less than or equal to 4/3 x minus 4. Problem 11. Well, let's see. What does this say about x? Absolutely nothing. My slope, it turns out, is 0. My y-intercept is -4. They've shaded above. I have a dotted line. Therefore, y is greater than -4. Is 0 greater than -4? Yeah, and x can be anything. That's why the line can go side to side. X can be anything. Okay, final problem of this sort. Okay. Y is strictly greater than, because it's shaded above, my slope is 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. Y is greater than 3/2 times x minus 5. On to the next page. Okay, now we remember that this is where we had corrections. A restaurant has small tables and large tables. Small tables seat 4 people each, and large tables seat 8 people each. Which inequality shows the maximum number of people that can be seated at the restaurant? Here we take words and turn them into math. Okay. Small tables, S, each seat 4 people. Large tables, each seat 8 people. Well, whatever number of small tables we have, we can put 4 people at each one of those. But we also have some tables for 8, and 8 times t that's the maximum number of people, right? We can put 4 folks at every small table, we can put 8 folks at every big table. So the total number of people could be equal to 4s plus 8t. Can it be more? No. Could it be smaller? Sure. You might have me at your restaurant for dinner and a group of 5 teachers, and someplace else you might have a group of 4 and someplace else a group of 2. So the maximum number of people could be equal to this. You could have every seat in the restaurant filled, or at the very least, it could be less than or equal to. Can it be equal to? Sure. So our correct answer here is B. Ticket sales total at least $7,600. So that's greater than or equal to 7,600. An adult's ticket is $7.50. Okay, what are we going to call an adult ticket. We'll call it A. A equals adult. C equals child. Okay, the number of adult tickets, we don't know what that is. A is the number of adult tickets. C is the number of children's tickets. So, however many we have, we don't know. 750 times the number of adults plus $4 times the number of children's tickets is at least $7,600. Does that make sense? Well, the total money from adults is $750 times that number of tickets. The total number of money from children is $4 times the number of children. They tell us that's at least $7,600. And again, you remember we had a correction. So maybe some weeks they sell lots of adults and no kids. Maybe other weeks they sell lots of children and not so many adults. But they always sell at least $7,600 per week of tickets. You remember we had a correction on this problem too. It's a good thing we knew about the correction because that's the right answer. Okay, a little more, then we'll be done with this page. Write the inequality but do not solve. We've pooled to our money. We have $12 to spend on lunch. So, less than or equal to $12 because we have no more money. We're going to share a large fry and buy hamburgers with all the rest. Okay, if the price of a large fry is $1.22 and the price of a hamburger is 89 cents, well, however many hamburgers we buy, 89 cents times the number of hamburgers plus $1.22 for that one fry is less than or equal to $12. If you have a question, email me. Dan wants to order DVDs. An internet company charges $19 per DVD, $4.50 for shipping and handling on the whole order. Okay. So, let D equal the number of DVDs the amount of money from DVDs is $19 times that number. He got a good deal on shipping and handling. I like this company. $4.50. Okay. However many DVDs he buys, each one costs $19. Shipping and handling is $4.50. At most $75. Can he spend $75? Yes, so it could be equal. Could it be less than $75? Shoot, yeah, man. If I can get a lot of DVDs for less than all my money, I'm happy to do that. There's my inequality. Miss Jones is buying pet food. Each can of cat food is 79 cents. And the dog food is 59 cents a can. Well, first of all, Miss Jones needs to be giving her animals kibble as well, because wet food only is not good for cats. They get urinary tract infections, and not good for dogs because they need more crunchy stuff. How much can she buy for under $7? So this is strictly less than $7. Let C equal the number of cans of cat food let's let D equal the number of cans of dog food. Now, how much money do we spend on cat food? Well, we don't know. We don't know how many cats and how many dogs she has, but 79 cents times the number of cans of cat food plus 59 cents times the number of cans of dog food less than $7. One more. Then we've got one more page and we're done. We are rocking. We can spend no more than $30 at a health club. $10 to use the racquetball court, $5 to use the tennis court. Find 3 possible combinations of racquetball and tennis court times we can use. Okay. Less than or equal to $30, because no more than means we could spend a whole $30. R equal number of hours of racquetball. T is equal to the number of hours of tennis. My R's look like T's. That's not so good. Okay. $10 an hour for the racquetball court. 10 times R, and $5 times the number of hours on the tennis court can be no more than $30. Well, okay, 2 are pretty easy. The first one is 0 racquetball, all on tennis. 5 times 6 is 30, so 0 racquetball and 6 hours of tennis. We could also have 0 hours of tennis and 3 hours of racquetball. Well, which do we like better? I've never played racquetball. I've played a lot of tennis. I'd rather be outside and play tennis. So what if we have 1 hour of racquetball and that's $10. Subtract 10 from each side. That gives me $20 left for tennis. 5 times 4 is 20. So that's 1 hour of racquetball and 4 hours of tennis. Did that make sense? Good, of course it did. Math makes a lot of sense when we slow down and think about it. Good job.